Hello YouTubers. It's been a while since I posted any videos on YouTube, so I thought I'd start with this. What I have is a very nice late 1920s electrodynamic radio speaker. It's quite a large cabinet. This is a Jensen speaker, and I got this from the estate of a ham radio silent key. And I don't have a radio. In my collection of radios and speakers, I don't have a radio that I have in specific mind to pair it with. But I'm thinking a late 20s AC set, like possibly a Radiola 18 or 19 or 17, I should say, 17 or 18 or 60, or the Brunswick version of the Radiola 60. Possibly a Colster AC radio, or one of the similar big chest AC radios that they made in the latter 20s. I'm not quite sure, but I don't have a radio to pair the speaker with, but I'd like to take a look at what we have here. I haven't really done much since I got this speaker, but if you can see, the grill cloth, a very nice shape, no rips or tears in it. The cabinet has some scratches on it, but it's not really bad. And then we look into the back, other than the dust that's still in there, I can see that the cone really looks nice. The cords, well, they're actually not shorted or ready to blow up if I put power on them. This, of course, has to plug in for AC line current. That's, of course, missing from the switch. Most of these electrodynamic speakers of the day had a switch like this in the cord to turn the speaker itself on and off. And here is the signal lead for the speaker. And the interesting thing is I can tell that the cord is not cut or frayed here, but the pins are missing. Just the pins are missing from the cord. But the cord's not very long, so I don't have a very long cord here. But now what I'm going to do is see what we have for DC resistances. And I'll set this up and see what we get. And I haven't, of course, put any power on this thing yet. Before I do that, I'm going to pull the speaker out of the cabinet and see what the electronics that looks like that runs the field coil. I know there are some people that actually do power these things up and without changing much in components, but I want to make sure that I don't have any capacitors or selenium rectifiers that might seem ready to blow up. Well, let me see what we get for the line input for, let's see, we have 73 ohms, 0 ohms. The switch might need to be cleaned. There we go. Now we got it. There we go. about 74, about 75 ohms here on the input. Let me reverse these once and see if we're going to get a different reading, maybe through the rectifier. Pretty much the same, 76 ohms. Okay. Now let's take a look at the voice coil and see what we get on the voice coil. And I hear a crackle from the speaker, even though that there's no power on the. So what do we have here? 300, about 365 ohms. Of course, for a 1920 speaker, that's low. Usually it's 1,000 to 1,500 ohms. But this, of course, the speaker is meant to work with probably a 171 amplifier tube, something of that sort. So I'm sure that that's probably normal for this speaker. And one more test I'm going to do before I pull the speaker out of the cabinet is I have a 9-volt battery here. We're just going to touch the lead, and I don't know if it's I don't know if that pop or crackle is coming through, but not only does it pop and crackle, but it's got a nice deep sound to it. So that tells me that this speaker is actually very good. So the next phase is I'm going to pull it out of the cabinet and see what I've got for electronics and what the cone looks like. Okay, I've got it out of the case and I pulled the metal side pieces off. So what we basically have for electronics, what I have here is we've got a choke here, and then there's a selenium rectifier stack here. Nothing looks sizzled or burned. I don't see anything in capacitors. There's some coils here underneath the speaker, and I could now tip this up and kind of look in there, and I'm seeing what I think are maybe some electrolytic capacitors. I don't know how good they are. If those things will blow up when I put power on them, I might have to investigate that. But the other thing is the cone. And as you can see, the cone is in very good condition. It's not rubbing. The voice coil's not rubbing. It's in very, very good condition. So this is a winner for an old Jensen electrodynamic speaker, and it'll be fun for me to find a radio for it. I think in the next video I do involving this speaker will be also involving connecting this up with a radio that I'm going to pair it with. So here is my Jensen late 1920s electrodynamic speaker project. Something that I'll be working on sometime in the future. Okay, I'm taking this just a little bit further. I've taken the bottom off, and I don't know if it'll show up in here, but and maybe not. But here is I'm sure is an electrolytic capacitor, and it's right here. And there's no way I would ever try to apply power to this speaker without first investigating this capacitor and more than likely replacing it. And I'm sure that maybe a 20 mic at 250 volts would be more than enough. But it definitely is going to need replacing. I'm going to have to definitely look at the polarity of it and see. I can't see anything marked on its cardboard shell, but it looks like it's kind of deteriorating apart as far as the outside paper covering. So that may not, if there was anything written on it, I may not be able to find that. But that's one of the things I'm going to need to do before I even begin to try to power this thing, is I'm going to need to replace that electrolytic capacitor. So that's what I'm going to do. Okay, and my investigation has enlightened me. What I thought was an electrolytic capacitor is not an electrolytic capacitor at all. This is something that's typical of 1920s radio. It's probably a potted RC network, possibly something to do with equalization. I'm not all that in the know on some of this stuff to know exactly what this thing does. But this has nothing to do at all with the power supply for the field coil. In fact, this is strictly in the audio circuit, and in fact, it's across the audio input. This goes across the audio input. Now, basically, to power up that field coil, you have this transformer, which probably reduces the voltage, the line voltage, down to a lower voltage. you have this selenium rectifier stack, and there's really no filterization, no electrolytic capacitor involved. Um, to be honest with you, this is the first time I've ever looked into a speaker like this. I've never had one apart. There are several companies that made electrodynamic speakers for the late 20s to go on radios of that period, but I've never had one apart until now. But I do know that this is not an electrolytic capacitor at all. There is no electrolytic capacitor in here. So I'm going to put this thing back together, and then what I'll probably do is very, very slowly I'll run the power up and see if I get smoke or what happens to this thing, but I'm going to give this speaker a test. Okay, I've got this thing wired up, and I've got this light bulb in series with the line just in case. What I don't want to do is I don't want to have this selenium rectifier stack blow up and burn up if I can avoid it. Because those, if you've ever experienced one of those blowing up, it's really really not something that's too good. But without any power on it, I'm going to test the voice coil. You can hear I get a nice pop and crackle from the 9-volt battery. So I'm going to bring up the power, and I'm going to bring it up quite slowly actually, and we'll see what we get. So here goes power, and I'm reading amps on my power supply meter here, and I'm seeing nothing in amps, and of course the bulb is not lighting. I'm probably at about maybe 50 volts, thereabouts. I'll bring it up a little bit more. I can hear a slight hum coming from the speaker. So let's just leave it at that and try the crackle test, and that's noticeably louder. So as we get some magnetic field in the field coil, it's getting louder. So now I'm going to bring the power up, and now I'm just seeing a little bit of amperage draw, not much. Still no visible light coming out of my light bulb. I'm pretty close to full power on this thing, and I can hear quite a nice AC hum in the field coil. I don't know what that's going to translate out to when you've got audio going through this thing, but and again, it's the crackle's much louder. So now take it up just a little higher, being careful, and that's about as far as I need to go with the bulb in series with it. The next step, of course, we'll take the bulb out of the circuit. Quite a nice crackle, and I hear a hum. I don't feel anything getting hot. So I think the next step is to power this thing up without the bulb in the circuit. Okay, so here's going to be the real test now. I've taken the light bulb out of the circuit, and again, before I put any power on the field, I'm going to do the crackle test. And it crackles, but fairly softly. The crackle doesn't have enough punch because there's no field, or no real field in the field coil. So now this thing is going to get full power now when I bring it up. So I'm going to just bring it up very slowly. And again, I'm reading amps, so I could quickly shut this thing down in case I start seeing any smoke or hearing any anything or see a spike in my current go up. So I'm advancing this still slowly, even though I've already run this up with the light bulb in the circuit. But now when I get this up, I have my dial marked, so I know approximately where 110, 100 to 120 volts is. Of course, without a load, you have to compensate for resistive load, which takes the current down. But I'm getting up, and I can hear hum in the field coil. A little bit more. A little bit more. My dogs think they're hearing something, but there's nothing to be heard. They're hearing ghosts. Well, so far no fire. I always am afraid that when you ever power something like this that's old and hasn't really had all parts replaced, I'm always worried that this thing is going to blow up in my face. I've had several things do that. In fact, quite recently I had a big electrolytic capacitor and can explode, not in my face, but it could have been. It was in a Leslie amplifier, and it really, really went up. It made such a loud boom when it exploded that the windows vibrated. Well, I'm pretty close. I'm right about at what I would consider to be full power. Nice hum there. AC hum. And quite a nice crackle because of that field being in there. So the next step is going to be to power this up and have a radio play through it. So we'll see what it sounds like. But you know, for something as old, 85 years old maybe, you look at this and it's amazing that this thing is still potentially a working speaker. How much stuff has been made in the 1980s, 90s, and 2000s that you would think would last 85 years like this. This Jensen speaker, I think, is going to be a very good working speaker. Next phase of my video is going to be when I'm actually going to play some radio through it.
This is not a total crippler. No, crippler.
So this is my King radio.
The area, and it appears the northern and western sections are
through my test speaker, my ever-ready test speaker.
You know, the possibilities we watch this thing, if this track shifts, that will have to be altered a little bit. But I think we're kind of laying out the general consensus of opinion right now. And it looks like pretty good snow there. They're talking about some places in Wisconsin get 10, 12 inches of snow out of this thing. Well, you wanted a white Christmas. Yeah. And you want a white Christmas. Yeah. All right, Tom, hang on. Okay, Gary. And the traffic is sponsored by PrimaSeal.net, Leslie.
On the Eden southbound, we're still at about 20 minutes.
Okay, so now what we're going to do is we're going to put I'm going to take the electromagnetic speaker, the electrodynamic speaker, and put it on and hear what that speaker sounds like on this radio.
We're at about 42 minutes.
Okay. This is how it sounds with the field coil turned off. So now I'm going to switch on the field coil.
Dream Girls created magic. Now Motown legends
and there we go.
And the Four Tops together.
Here is the Jensen electrodynamic speaker from the late 20s. Still playing, and I didn't have to do much of anything to this speaker, really. And think about stuff that's been made between 1970 and today. Would it last this long? Who knows?
So relaxing, but there may be danger hiding right in your fireplace. Every year, creosote buildup causes thousands of chimney fires.
So there we go.
Attack that buildup with CSL, the creosote sweeping log. Each time you use your fireplace or wood stove, there's a constant buildup of thick wood smoke deposits in your flue called